Hi everyone, let's take a look at the following example. Copy each graph of f of x and then graph and label each related function. Part 1, g of x equals to 3 times f of x. Again, if you think about the transformation in words, this really means you're looking at a vertical stretch or a vertical expansion, if you like, by a factor of 3. So what that means is in terms of the mapping rule, xy is now mapped to x and 3y. Now, if I go back to the function f of x on the right, you have to pick 2 points. So for example, there's a point right there. That's -1, -1. There's also the second point, 1, 1. You also want to be mindful there's the horizontal asymptote at y equal to 0. There's also a vertical asymptote at x equal to 0, something that you want to think about as you're graphing g of x. So what this means is x remains the same. You have -1 and 1. If you look at the corresponding y values, you multiply by 3. -1 times 3, -3. 1 times 3, that's going to be 3. So now, if I go back, and maybe I should use the same color, so I'm matching everything for you. I am graphing g of x, which again equals to 3 times f of x. I look at the point -1, -3, which is down here. I also look at 1, 3, which is going to be right there. Now, think about the asymptotes. The horizontal asymptote is still going to be at y equal to 0. If you think about the vertical asymptote, it's still going to be at x equal to 0. And the only difference is the vertical stretch. Now, if you want to grab more points, you could, by the way, but the graph, roughly speaking, is going to look something like that. Same thing on this side. And I'll label this as g of x. Now, in a different color, let's move on to part 2. I'll do part 2 up here. If you think about h of x, which equals to f of 4x, again, in words, you would say this is a horizontal compression by a factor of 1 divided by 4. And in terms of the mapping rule, this is basically x divided by 4, and y remains the same. Again, you can grab the same original points, -1, -1, and 1, 1. Now, if you want to grab more than 2 points, by the way, feel free. You can grab 4 points, 5 points, 100 points, but I'm just going to give you kind of the major concepts here. If you look at the x values divided by 4, -1 divided by 4 is -1 divided by 4. Likewise, 1 divided by 4 is 1 divided by 4. The y values remain the same. Again, when you think about the new graph, the horizontal asymptote is still going to be at y equal to 0. When I think about the vertical asymptote, it's still going to be x equal to 0. And the difference here is that the new point is going to be -1/4, so left by 0.25 and down by 1. Same idea, I go right by 1 divided by 4, up by 1. And again, the graph will look, roughly speaking, something like that. And you can label this as h of x. And again, h of x in this context is going to be f of 4x. Let's pick another color for you. Here we go. Part 3, m of x equals to f of 2x. So just like part 2, this is a horizontal compression by a factor of 1 divided by 2. You can say 1 divided by 2 times x. You can say x divided by 2. It's the same thing at the end. Again, I start with the original points. I take the x values and I multiply by half. Half times -1, -half. 1 times half, that's going to be half. The y values I copy as is. So again, I go left by half this time, down by 1. I go right by half this time, up by 1. And again, the graph will look, roughly speaking, something like that. And I can label this as m of x. Again, recognizing that m of x equals to f of 2x. Don't forget, the horizontal asymptote is still going to be at y equal to 0. The vertical asymptote is still going to be at x equal to 0. Now, I would like you to try part 4. So press pause and go through all the steps. When you press play again, I'll be here. Welcome back, everybody. Let's finish strong. So in part 4, which I'll write in this corner here, f of x divided by 5. So you're looking at the new function, r of x, which is basically f of x divided by 5. In words, this is a horizontal stretch by a factor of 5. So 5 times x y remains the same. I grab the original points, -1, -1, 1, 1, and 5 times -1 is -5. 5 times 1 is going to be 5, and y remains the same. So this time, I go left by 5, down by 1, I go right by 5, up by 1, again recognizing that the horizontal asymptote is still going to be at y equal to 0. Recognizing the vertical asymptote is going to be at x equal to 0. And again, the graph, roughly speaking, is going to look something like that. I can label this as r of x. And that's it. That's how you graph these transformations. If you find this video meaningful, please comment, like, share, and subscribe. I hope this makes sense.